Good day, folks. I wanted to create a video that you guys could go over on your own time again and again to understand how to calculate insulation in a wall. So to start with, let's look at a few things. I'm going to open up a couple of things here so that we can discuss them and talk about how we're going to do this. So this is a wall section that is looking down on the wall. So we have taken a wall and we have cut it and we're going to look down on it. So let's say that we're taking this house here and we're going to take a section of the wall here and we're going to cut it and we're going to look down on it. Okay, so if I go over to the plan, then we may take a specific section of a wall. Maybe we're going to take this section here and we're going to analyze it and figure out the proper insulation on that. So let me find my way back over here. Okay, so insulation is something that just goes through the inside of the wall, and we normally think, okay, so it's an R13 or it's an R16 or something like that we put in the wall. But actually, there's a whole bunch of stuff that takes into play here. So let's go over here and look at this R value table. So in the R value table, we have lists of different materials that have actual R value connections. So let's step back just for a second. So there's two things that we look at. One is a U factor, and a U factor is the speed in which heat passes through a wall or a material. All right, so a piece of glass, piece of metal, it's going to pass through there very quickly. All right, so then if we had, let me just open this up right quick, a new one. Okay, so the U factor and the R value. So that's what we're going to be talking about today. So the U factor equals the speed in which heat transfers through material. And the R value is the resistance of heat flow. Okay, so that means that this one here is saying, well, it can pass through a material at a certain speed. And like I say, a piece of steel, aluminum, this has a very high U factor rate because it passes through it very quickly. When we think about insulation, then insulation has resistance. So the higher the resistance, the slower heat is going to transfer through there. So these two are relative to each other. So the R is equal to 1 over the U, and obviously the U is equal to 1 over the R. All right. So let's say that we have a window, and most windows and doors are sold with a U factor rather than a R value. So the window has a U of, say, 0.33. Okay, we'll keep it simple. So if we say 1 divided by 0.33 equals 3.3. All right, so that was pretty simple. So that is an R, that is an R 3.3. Now, in a wall in North Carolina, North Carolina code says that you must have an R value, or an R value of 13 plus 2. All right. So what that's saying is, let's go back over to the picture here. That's saying that we have to have an R13 insulation in this cavity here, but then we're supposed to have a skin on the outside of it called a thermal skin of a of an R2. So total, this gives us an R15, but it's not going to be an R15 here, and it's not going to be an R15 here. It will be an R15 here because we have the R2 plus the R13 here. So the reason that we have the R2 in here is to kind of increase our R value where we go through studs and where we go through gaps, and we have gaps in there. So that is the way that we look at that. Now, in floors, the R value in North Carolina is a 19, and for ceilings and roofs, it is equal to an R30 or 38, and I'll explain what that means here in just a second. So let me go back over here to this wall section here. Let's find the wall section. Do we have a wall section? I don't have a wall section in that one. What about this one? I do have a wall section. Okay, so let's look at this wall section. So I have an R15 bat in here, and yes, you can buy an R15 bat. And so if I have the ceiling insulation and it goes to here, and we are able to maintain that R30 all the way to the outside wall here. Sorry about that. Okay, so all the way to the very outside without contamination or reduction in an R value, then we can use an R30. If we can't, for some reason, get the space that we need in here, and this starts degrading, and that happens a lot, especially in older houses, then we have to go with an R38. So, or for some reason we can't get this all the way to the outside, then this has to be an R38. So that explains the R30 or R38 there, and I hope I made myself clear on that. So when we're talking about this wall here, we have a couple of different things that have influence on our wall. So obviously here I've said that we have an R13 and we have an R2 that is our thermal skin. But over here, if we draw a line through the framing of our wall here, we have a great big stud here that is not going to give us an R13. And then if we have gaps, then we're going to have a problem there as well. So let me go over here and talk about wall insulation. Find some pictures to kind of talk with that about. So this is obviously a terrible way to insulate. Okay, very sloppy job. Anytime that you can see the studs, then it's a terrible job. Okay, so you talk about gaps. We've got massive gaps here, and we have gaps here. See how that's pushed in right there? That is not cool. That is not the proper way to do insulation. When you do insulation, you shouldn't be able to see any studs if you're using a crafted insulation. So let me see if I can find a good, here's another one. Here, let's talk about this for a second. This is great. So here we've got a wall that has compressed cellulose or packed cellulose, and then we have the typical bat. Now this is uncrafted, meaning that it doesn't have paper on it. And they did a terrible job here because they didn't cut the insulation to wrap around these pipes. They didn't cut the insulation to wrap around the electrical box, which here is better. and then obviously they cut to go around the wires. So when we do something like this, we can be able to cover around it much easier. Here we have to cut, and it takes a little bit more time to get it all in there. Let me see if I can find a really good picture. Most everything I see is done wrong, and when I say done wrong, well, this is okay because it doesn't have craft on it, and there's no gaps in here. This is sprayed on foam here, so obviously we can spray it in, and it clings around everything. Another one here, very good spray foam, and they've actually oversprayed there and then have to cut it off, which is actually the best way to go. Let's see, let's change the word. Wall bat insulation. So let's see. Golly, every one of them has terrible has been done in terrible. See all these gaps here. Okay, so this is a bad picture. Let me see if I find a better picture. All of these look bad. Wow, that's pretty sad. Change the wording a little bit more. Proper wall insulation. Whoop, hit the wrong one there. Not that one. This one. Okay. So let's open up this. All right. You see how these got the little tabs here? And over here, he hasn't got to this point here yet. But these little tabs actually cover the studs, so you don't see the studs there. That is proper way of doing it. And then he's cutting out this little section here, lessening it, and then shoving it in behind this box. So if we compress it, then we're doing a disjustice on ourselves, because we're turning that fibered glass back into glass, and obviously glass is a conductor of heat. So here's a good one as well, I think. Didn't want to do that. Open. All right, so again, you can see these tabs have been folded over each other, and it's been properly installed. Then when the drywall or whatever interior finish is going to be put on, then there are no gaps whatsoever in between and around the insulation. So that's a very good way to do it. Here is another incidence of not how to do it. So they've turned these tabs, and they're nailing it into the side. So in a sense, when we go to put this on, let me go over here to CAD right quick and draw you a picture. So here is our wall, 3.5 inch. And we have a stud. That's going to offset 1.5 inch. I'm just going to copy that. Now let's do one more thing so you know that it's a stud. And now let's copy all of that. Copy. Bam. We're going to go over 16 inches. There. So now we have a stud cavity here. And if those tabs, let's change to a different color. If those tabs are placed in here to the side, then when our insulation goes in, then it's going to look like that, because we have those tabs in there. The tabs should be out here. So this is bad. We have this little space here that is called a gap. That's going to be behind the drywall. So the drywall is at this point. Here's the drywall. So we put the drywall up. Obviously, you can see that there's going to be a gap there. This is bad. This is bad. So we don't want to do that like that. We want to put our tabs to the outside, and they would cross over each other. When we put that in there, bam, then we have our insulation that is going to run right up against the drywall across the entire span of that cavity, and that's the way it should be. That's the proper way of doing it. And like I say, this is not. So obviously we're going to have more gaps in here. So when we go to do our calculations, I will give you the percentage of gaps and the R value of the gaps. So obviously, even though we have an R21 insulation in this wall, right here we don't have R21, and right here we don't have R21. So that is what we have to do, is we have to go through and determine how our, well, let's get back to where it was. Where was I? I was in a picture somewhere. So we have this. Where's that picture? Did I close it by accident? There it is, sorry. Okay, so over here on this page here, at the top of the page, it gives us a little short little calculation on how to figure out the R value, okay, of the assembly. But now we have 3 different spaces in which we have to calculate this. We have the frame, which obviously goes through our stud. We have the insulation, which is going to be a very nice high number because it goes through all the insulation. And then I just kind of show an electrical box here as the gaps because this would be less. So we would take and cut this insulation and place it back here. So if this is, say, an R13 at this point, obviously we can't have an R13 here. So we have to determine what that would be, and I would give you that as well. So a couple of things that we have else that we have to take into consideration is we have an exterior air film and we have an interior air film. So the exterior air film and the interior air film is basically this re-radiating energy off of it. So this wall here, if it's the temperature in here is 70 degrees, the outside temperature is 40 degrees, then this is going to have embodied energy in it and it can re-radiate. So we always figure in an air gap in there. We have our outside finish, which might be siding, which might be brick. It could be a whole different number of things. We have our sheathing, our substrate that's going to be in there. Sometimes we have our thermal skin that we count. And then obviously we have our studs, and they can be at 16 or 24 inches on center. Inside finishes is gypboard, paneling, rock, tile, any kind of number of things like that. So when we go to figure that, we're going to look at these 3 sections right here and what goes through that line. In the frame here, we're going to have the air, the exterior air, we're going to have the exterior finish, we're going to have the sheathing, we're going to have the stud, we're going to have the drywall, we're going to have the interior air. Insulation, we go through exterior air, outside finish, sheathing, the cavity itself, which is going to be filled full of insulation, gypboard, and inside air. The gaps is going to be exterior air, outside finish, sheathing, very little insulation. So this section here is going to be a very small number, and then drywall. Even though I don't show it through there, we will count the drywall at this point and the interior air film. So that kind of gives you a rundown of what this here is, and so we have to fill in all of these numbers here. So let me go back over here and open up the calculation sheet. I'm going to make it a little bit simpler for me, and I'm going to open up the insulation calculation sheet with the calculations in there, and I will give that to you so that you can run it through. So when we're looking at this, you can obviously see that I've already added in a couple of factors here. The 0.17 is the exterior air and the interior air film is 0.68. I get that from the very bottom of the page here on our R value table, and I am always going to figure out for winter, because we have our winters are usually colder than our summers in this point. So I'm going to use the interior wall of 0.68. I'm going to use an exterior wall of 0.17. Okay, and that's where I get those. So when we go to look at this little sheet here, let's figure out what we've got going on here. So in the framing, let's say that we have a 2x4 wall. Okay, so we have 2x4s, and I'm gonna give you a percentage of the framing. So the percentage in framing is going to be based on if it's 16 inches on center or 24 inches on center, or if they framed the heck out of everything and added a whole bunch of extra gang studs, or if we were using advanced framing, which means that we're going to reduce the amount of framing so that we can get more insulation. So in this case here, I'm going to use 17%. We'll put in 17% framing. Since it's a 2x4 wall, the best I can really get in is an R13. And then the gaps is always going to be less than what the real insulation is. So I'm going to give this is an R9, and the gaps in here are 3%. We've done a fairly good job. We've put the insulation in correctly, and we're going to go with 3%. So a couple of things I'm going to do. First of all, I'm going to transfer these numbers down here. So right here we have the percentage of framing, insulation, and gaps. I've given you 17%. I'm going to write in 17 at this point. Automatically, this changes to 32. If I've got 17% framing, I can't have 100% insulation, so that jumps down to 83. My gaps are my gaps are 3%, so I'm going to put in 3 there, and this does the calculation for you. And so I'm going to have 80% of insulation in the walls, 17% framing, 3% gaps, okay, at that point. Okay, so I have to figure out what's going on here. So what kind of exterior finish do we have? Do we have sheathing? What kind of interior finish do we have? Let's keep it simple, and I'm going to say that we have wood siding, and we have, let's see, we have wood siding, we have 1/2-inch OSB sheathing, OSB sheathing, and we're going to have 1/2-inch drywall, 1/2-inch gypboard. Okay, so we've got to look these up before we can put that in there. So obviously the air film, okay, remember that we have framing, insulation, gaps, and when we're looking at that picture, that picture always deceives me. That picture, we got framing, insulation, gaps. Let's go back over here. Framing, insulation, gaps. So this line through here is going to be the calculations of everything that goes through that line right there. Everything that touches that line. The insulation is going to be everything that touches this line. And then obviously the gaps are going to be everything that touches the gap line. Okay, so when we go through here, we see that the exterior air goes through 1, 2, 3 all 3 of these cavities, and that's why when I put this number in, it transfers all the way over. Notice that the interior air does the same thing. Well, so does the outside finish. The outside finish in this one is wood siding. So let's go over to our sheet here and look for wood siding. We have sheathing materials, we've got insulation materials, so we've got to find wood siding. Siding material, here we go. Wood bevel lap, that's what I'm going to go for. I have a 0.8. So in here I'm going to put 0.8, and automatically it transfers over because this exterior finish goes through 1, 2, 3 of these lines. So does the sheathing. The sheathing goes through all 3 of these lines. So right here I need to look up 1/2-inch OSB. So I'm going to go back over to the Rvalue table, and OSB and plywood are considered the same, and I have a 0.63. So right here I'm going to put in 0.63. Obviously it carries, sorry, hang on, bam, delete, 0.63. All right, so that is my sheathing, 0.63, and I got that again right there, wood beveled siding, 0.8. Wait a minute, sorry, wrong roll. I got that from 1/2-inch plywood, 0.63, and that's where it goes through all 3 of those. Now, when we're into the wall cavity, let's go back over to our picture. Our wall cavity, which is between this black line and that black line, those things change. All right. This one goes through the frame. This one goes through the insulation. This one goes through the gaps. Obvious, that's where we get their names from. So when we're looking up for a stud, we have a 2x4 stud. Let's go up here to construction materials. Half a 2x4, which is 3.5 inches. So when we're looking at our picture again, we're not counting this way at 1.5 inches. We're counting this way at 3.5 inches. So at 3.5 inches, oh, and by the way, this column here, this first column is inches. All right, so these numbers here represent the R value per inch. These numbers over here are the R value for whatever thickness it says over here. So we have all this bad insulation, and it's giving us a specific thickness. They've done the calculations for us, but if we use just bats, fiberglass bats, then we have a variance there that goes by. So when we buy this, then this is what it is actually the actual R value of that. So we come down here to 2x4, 3.5 inches. We have 4.38. So over here in my little calculation, I'm going to put in 4.38. All right, and I knew that was going to do that, and I didn't want it to do that. Okay, so because these are not going to be the same. These are all going to be different. The insulation, what did I tell you the insulation? R13. So I'm going to put in 13 right there. What about the gaps? I told you it's going to be an R9, so I'm going to put the R9 in there. Excuse me. So now we have the wall cavity all figured up. We have our framing, we have our insulation, we have our gaps. Now we got to do for the interior finish. Our interior finish is gypboard. Excuse me. Sinuses are acting up. We have 1/2 inch gypboard. So let's go back over to our R value table, and we should have interior finishes. We do interior finishes, gypboard, drywall 1/2 inch, 0.45. So let's go back over here and type in 0.45. Boom! It goes all the way across through all of them. The drywall goes through all of them. Like I say, I didn't show it here, but it actually goes, we count that going through the gaps. All right, at this point, what we do here, this column is added up and put into to this bottom column here. So this is the sum of everything above it. This is the sum of the insulation. This is the sum of the gaps. So looking at this R value here, 7.11, that if we shot a line right through here with a thermal imaging camera, then we can determine that this is going to have a 7.11 R value. The insulation is always going to be highest at 15.73. So right here, it's 15.73, and then 11.73 down here on the gaps. It's always going to be smaller. This is always going to be bigger, okay? And these two are going to be smaller than the insulation. So these are placed down here because we have a percentage in this wall here. Then these need to be weighted. So for simplicity, I'm going to say that we have 1,000 square feet of wall area. When I put that in, 1,000, let's see if I put it in here. Does that change it? Yes, okay. Bam. 1,000. Okay, so I got 1,000 feet that I put in there. So I took 1,000 and I multiplied it by 0.17 equals 1,000 times 0.17. Bam. So we have 170. So all that calculation is done for you. 80% of this wall is going to be 800. 3% of this wall is going to be 30. See that right there? Keep that in mind. A over R. A divided by R. That means area, there's the A, divided by the resistance, or the R value. So I'm going to say equals 170 divided by 7.11. Bam. There's that number right there. 2391. Just rounded it up to 2 decimal points. All right, so it did that for all of them. 800 divided by 15.73, 30 divided by 11.73, and that's where these numbers come from. Okay. Again, this number here is going to be a sum of these top three numbers. We're going to add them all back together to end up with a 77.33. Now, again, A over R, if I take the total area, which is 1,000 square feet, and I divide it by the total R value, equals 1,000 divided by 77.33, I get 12.3, and there's that number there. So the average weighted for this picture here, all right, the frames were weighted at 17%, 80%, 3%. We add them all together, we take 1,000 square feet, total area, divide it by the total R value, then this is going to be our average R value for the wall, per wall. So what's that saying is that as a whole, this whole wall can be figured at a 12.93, which really falls well below the state code if we look at it. Now the state code does say 13 plus 2. So we did put our 13 in right here, but we didn't put our plus 2 in anywhere. All right, so let's go back and let's say that we have some XPS in here. So we're going to go in our wall here. We're going to take our siding off, and we're going to put some sheathing. We're going to put our thermal skin in front of our sheathing. All right, so we're going to put an XPS in there. We're going to say that we have a 1/2 inch of XPS. So XPS in our insulation here is going to be extruded polystyrene, blue board. It is 5 per inch. So what is half of 5? That would be 2.5. So we're going to put in 2.5, and that changes everything. All right, so by putting this skin in, the thermal skin at 2.5, all the way across all three of these planes, that increases all of our numbers. Our area stays the same, our percentages stay the same, but look what it done to our R value. Remember, 13.2 was our state code. 13 plus 2 is 15. Now we have a 15.7. We have our 13 plus 2.5 actually, so we're half R value higher than what the state requires. All of this added together and gets us well above the average that we need to be, 15.7. So I hope this helps you to understand how to figure out the R value of the table. So we have our R value table. We have our circumstances of what might be in your walls. We plug in the numbers from the R value table, do our calculations. These are all added in. We transfer those down and give them weights. And then we divide that by the area, and then divide it by the total to get our average wall here. Thanks, guys. I hope this works out for you. And if you have any questions, give me a text, 828-446-7474. Have a good one, guys.